Hello student, today we will be solving the IB Math A AGL May 2025 paper 1 time zone 3 question number 11. You will be getting the solutions for the first 10 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the short past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math A AGL level tutor from India. My phone number and my website address are given below. So without any further delay, let us start to solve this question 11. The maximum mark is 18. The points E with coordinates 1, negative 4, 0, point B with coordinates negative 3, negative 6 and 2, point C with coordinates -1, -2, 4, and the point D form a parallelogram ABCD, where D is diagonally opposite to B. That means this may be the parallelogram AB and CD. D is diagonally opposite to B. Okay. Part A's question is find the coordinates of the point B. Okay, because ABCD is a parallelogram, therefore the opposite sides of a parallelogram are parallel and equal in magnitude. So the vector AB should be equal to the vector DC. AB is in this direction, DC is also in this direction. Okay. So since ABCD is a parallelogram. Okay. Let D have the coordinates X, Y, and Z. Okay. So AB vector is what? B -3 -1 -6 and minus of -4, and finally 2 and 0, 2 minus 0. Okay, so therefore AB is equal to -4, and -6 plus 4 is -2 and 2. Okay, what is DC? DC is equal to C is -1 and D is X. So -1 minus X, then -2 and -Y and 4 and 4 minus Z. Okay, so therefore -1, negative X, -2, negative Y and 4 minus Z is equal to -4, -2 and 2. Therefore, -1 minus X is equal to, we will be equating row by row. So -1 minus X is equal to -4, or X equal to -1 plus 4, that is X equal to 3. Okay. Next equation, -2 minus Y is equal to -2. I can actually add +2 to both the sides, and these two will be getting cancelled. So therefore Y is equal to 0. Third equation, 4 minus Z is equal to 2, implies Z equal to 4 minus 2, or this is equal to 2. Okay, so the D's coordinates will be, therefore D is having the coordinates as 3, 0, 2. Okay, the diagonals of the parallelogram AC and BD intersect at point E, AC and BD, and they intersect at this point E. This is not C, this is E. Okay. So part B's question is find the coordinates of the point E. Now we know that the diagonals of a parallelogram bisect each other. If you remember this property, you can simply find the midpoint of either AC or BD. That will be giving you the coordinates of the point E, and I'll be using that method. Okay. So it is carrying 2 marks. Okay. So E will be having the coordinates. I'm taking AC. So 1 plus minus 1 over 2, comma, minus 4 and minus 2 plus minus 2 over 2 and 0 plus 4 over 2. Okay. So therefore E 1 minus 1 is 0, minus 4 minus 2 is minus 6 over 2 is minus 3 and 4 over 2 is 2. Okay. So these are the coordinates of the point E. Subpart C, it is having 2 further subparts. The first subpart I is saying, given that the vector product of the vectors AB and AD is equal to m times this vector, column vector minus 1, 1 and minus 1, where m is a positive integer, find the value of m. Okay, so we have actually found AB. We have to get AD now. Okay, so AB vector is equal to minus 4, minus 2 and 2. Okay, I'm just reading this. AB vector is minus 4, minus 2 and 2. Okay, and now coming to AD vector. D is 302. Okay, let me write the coordinates over here so that you can see and even I can see. So 302, 3 minus this one, 0 minus minus 4 and 2 minus 0 is equal to 2, 4 and 2. Okay. So now we need the vector product of AB cross is AD. This is equal to and first is AB, so minus 4, minus 2, 2, then AD 2, 4, 2. This is equal to minus 4, minus 8, I, minus 8, minus 4, J. I assume that you know how to find the vector product, and plus minus 16 plus 4 K. Okay. So therefore, AB cross AD is equal to minus 12I plus 12J and minus 12K, which can be written as in the form of a column vector because they have asked us to write it in this form. So it is therefore AB cross AD is equal to, I can take out negative 12 or positive 12, but over here they are saying m is a positive integer. So I have to take out positive 12, and also I'm seeing the minus 1 is inside. So I can write it as 12 and minus 1, 1 and minus 1. Okay. So therefore, m is equal to 12. Okay. I, hence find the area of the parallelogram ABCD. So, area of parallelogram ABCD, it should be the magnitude of this vector product. Okay. So, this is equal to, I can keep the 12 as it is. 12 is a number and I have to get the magnitude of this vector. So, it is minus 1 whole square plus 1 square plus minus 1 whole square, which is equal to 1 plus 1 plus 1 is 3. So, it is 12 root 3 square units. Okay. Now, the plane pi 1 contains the parallelogram ABCD. So, Paddy is saying find the Cartesian equation of pi 1. Fine. So, what is the Cartesian equation of any plane? It is n dot r equal to n dot a. N is the normal to the plane, normal vector to the plane. R is the position vector of any arbitrary point lying on the plane. And A is the position vector of a specific point with known coordinates on the plane. Okay. So for getting a specific point, I know A, B, C, D, all these 4 points lying on pi 1. So I can take any of them. Let me take the very first one, the point E, with coordinates 1, minus 4 and 0. Okay. So A 1, minus 4, 0. Okay. And what is N? AB cross AD will be giving us a vector which is perpendicular to both AB and AD, and AB and AD are non-parallel vectors because A is the common point between them. So these are two non-parallel vectors which are lying on plane pi 1. Hence the vector which is normal to both AB and AD is normal to the plane which is containing these two vectors. That is, this one, I can take this entire vector minus 12y plus 12j minus 12k, or this entire thing as the normal vector, or else I can take only this part, because this multiplying with this 12 will be just changing the magnitude. The direction will still be the same. So I need the direction, not the magnitude. Hence, I'll be taking the normal vector as minus 1, 1 and minus 1. Okay. So equal to minus 1, 1 and minus 1. Clear? So therefore, now we have to get n dot a. Minus 1, I'm writing minus 1, 1 and minus 1 in place of n. Dot r, it is xyz, is equal to minus 1, 1, minus 1. Dot, the position vector of this point A is 1, minus 4 and 0. You can take any of the 4 points. You'll be seeing, you'll be getting the same equation because it is the same plane. You have to get the same equation. Okay. So this is minus x plus y minus z equal to minus 1 and minus 4. This is 0. Okay, I can write plus 0. So therefore, this is minus x plus y minus z is equal to minus 5. This is the Cartesian equation of the plane pi 1 rather. Okay. Fine, we have answered part D. A second plane pi 2 has Cartesian equations 5x plus y minus 7z equal to 1. Okay, and the acute angle, this is important, between pi 1 and pi 2 is theta. Sapati's question is show that cos theta equal to 1 over 5. 1 over 5. Okay, first of all, let me write the equation of pi 2. 5x plus y minus 7z equal to 1. Pi 2, 5x plus y minus 7z equal to 1. Okay, and this is pi 1. And what are the normal vectors? Normal vector n1. I can write this also as n1. This is minus 1, 1 and minus 1. And n2 is equal to 5, 1 and minus 7. Okay. And if we do the the dot product of these two vectors, what we get? We get n1 dot n2 equal to the magnitude of the vector n1 times the magnitude of the vector n2 times cos theta. Okay. And rearranging the terms because we need cos theta. So this is cos theta equal to n1 dot n2 over the magnitude of the vector n1 times the magnitude of the vector n2. Now, since they have said theta is an acute angle, cos theta value will be positive. If and whenever theta is an acute angle, you should be having the positive value for cos theta. Now, this magnitude of n1 and magnitude of n2, these two will be positive numbers. But the dot product of these two numbers may be a positive number or may be a negative number. But we need a positive value because for acute angles, cos theta values should be positive. Hence, you will be taking the absolute value of the dot product. Okay. So that to ensure that you are having a positive value on the right side. So now let us do the dot product of these two vectors. n1 dot n2 equal to minus 1, 1 and minus 1 dot 5, 1 and negative 7. So this is minus 5 plus 1 and plus 7. Okay, 7 plus 1 is 8 minus 5 is equal to 3. Okay, so we are having a positive value for this dot product. So the absolute value is not needed because we are actually having a positive value. And for the magnitude of n1, we had found that previously also. It is equal to square root of 3. And magnitude of n2 is equal to square root of 5 square plus 1 square plus negative 7 whole square, which is equal to 25 plus 1 plus 49. And 49 plus 1 is 50, 50 plus 25 is 75. So this is equal to square root of 75. Okay. So therefore, cos theta is equal to 3 over root 3 times root 75. And what is this root 75 equal to? 75 is 3 times 25. So it is root 3 times root 25. Root 25 is 5. If you are confused, this is 3 times 25. This is square root of 3 times square root of 25, which is equal to square root of 25 is 5. So it is 5 root 3. Okay. So 3 over square root of 3 times 5 root 3. And root 3 times root 3 is 3. So I can cancel these. So therefore, cos theta equal to 1 over 5 shown. Okay. Line L passes through E and is perpendicular to plane pi 1. The line L intersects the plane pi 2 at point F. Subpart F's question is find the coordinates of the point F. It is carrying 5 marks. Now, I am very bad in drawing these things. I'm trying. Okay, so assume this plane to be pi 1 and this plane to be pi 2. And maybe this point is E, and this is the line which is perpendicular to the plane pi 1 and passing through E, and this line, this is L. This line may be intersecting the plane pi 2 at point F, and we are required to get the value, the coordinates of this point N. Okay, so this is the best that I could draw. And now what are the coordinates of this point E? What did we find? The coordinates of point E to be 0, -3 and -2. 0, -3 and 2. Okay, 0, -3 and 2. Because in order to get the equation of a line, what should we be doing? We will be finding the equation of the line L, and then we will be finding the general coordinates of any point lying on the plane L, and we will be substituting those coordinates in the pi 2's equation, because the general coordinates will also be satisfying this F, will also be referring to this point F, and since F is in pi 2, so the coordinates should be satisfying the equation of pi 2. That is how we will be finding the parameter. It may be lambda, it may be t, it may be mu, anything. Okay, so that is what we have to do. First of all, we have to get the equation of the line L, and in order to get a line's equation, a vector equation of a line, what information do we need? We need the position vector of a point which is on the line, and we need the direction vector of the line. So the position vector, we know that the point E is on this line L. So we are having the position vector. And what about the direction vector? The direction vector is the normal to the plane, because this line is perpendicular to this plane pi 1. So the perpendicular to this, the normal to this plane pi 1, that is N1, should be parallel to this line L. So that can be taken as the direction vector of this line L. Okay, so L will be having the vector equation as 0, -3 and 2. And let me take the parameter as lambda. Lambda is any real number, and the direction vector was -1 or +1, -1, 1 and -1. Okay, lambda is any real number. So what are the general coordinates? General coordinates will be minus lambda, 0 plus minus lambda is minus lambda, -3 plus lambda, and 2 minus lambda. Okay, and now what is the pi 2's equation? It is 5x plus y minus 7z equal to 1. Okay, 5x plus y minus 7z equal to 1. This is pi 2. Okay, and now I'll be substituting minus lambda for x, -3 plus lambda for y, and 2 minus lambda for z. So therefore 5, in order to get the value of lambda, minus lambda plus -3 plus lambda and -7, 2 minus lambda equal to 1. So this is -5 lambda minus 3 plus lambda -14 plus 7 lambda equal to 1. So 7 lambda plus 1 lambda is 8 lambda, minus 5 lambda is 3 lambda. And this is minus 3, this is minus 14, so minus 17. If we add 17 to both the sides, we get 3 lambda equal to 18 or lambda equal to 6. So therefore, coordinates of point F will be minus lambda, it is minus 6, minus 3 plus 6 is 3, and 2 minus 6 is minus 4. Okay. So thank you for staying with me till the end. Please like and share my video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question 12 of the same paper. Till then, bye.